Ophir's Sensor Finder allows you to easily find the sensor that best suits your application. If you're working with LEDs or similar sources, whose beams are usually divergent and have a broadened spectrum as opposed to the parallel monochromatic emission from a laser, there are different parameters we need to take into account in order to choose the right solution. For this reason, we have the Advanced LED Sensor Finder. This LED Sensor Finder includes all the features of the basic sensor finder, with added options for diverging beams, broadband wavelengths, and measurement of irradiance or power density. In many LED applications, such as UV curing or antibacterial treatment, the parameter of interest is irradiance in watts per square centimeter incident on a surface, rather than the total power emitted from the source. So the LED Sensor Finder has this option built in and can recommend sensors specifically for this type of measurement. Let's have a look. Let's consider a typical UV LED array for industrial applications, something like UV curing of adhesives, for example. Such LED modules typically look something like this. First, we select the beam type. Note that if we select collimated, it reduces to exactly the basic sensor finder. In our case, the beam is divergent. These LEDs usually have a spectral bandwidth of about 20 nanometers or so, as opposed to LEDs for some applications that emit white or colored light. So here we'll select single wavelength, CW, and we'll select flat top, although for a divergent beam it doesn't really make too much difference. As we saw, the beam is rectangular. And in such applications, the critical parameter is the irradiance on the surface. So we'll ask the sensor finder for a sensor to measure irradiance. Now we'll enter the parameters. Source size is, let's say, 75 millimeters by 10 millimeters. Divergence angle could be 30 degrees by 60 degrees typically. The source is typically just over the target surface. So we'll enter distance from source to sensor of 1 millimeter. Wavelength, 395 nanometers. Total power of such LED arrays could be some 40 watts. Note that this gives a calculated irradiance or power density of about 5 watts per square centimeter on the surface. We want a sensor that will actually measure that for us, of course. We click on Find Sensor, and the LED Sensor Finder recommends the PD300RM8W, which is a sensor optimized for measuring irradiance and dosage of UV and visible LEDs. If you still need help, for example, if the sensor finder doesn't manage to find you a solution, you can save your search data and email it to us, or just contact us through your local Ophir representative or directly, and we'll be happy to help you with your application.